Okay, I think this is going to be part one, but today what we're looking at is a toy from 1969. It was sold, this particular version was sold as Mr. Astronaut, and it was made in Hong Kong, and it's a very large, as you can see, plastic robot. Let me get the ruler over here. Let's see how, get the size of this guy. Alright, so you're about 13.5 inches tall. It's battery operated, walks, swinging arms, lit eyes, 2D cells. And basically this thing is just propped up there. In fact, it's being held together with a rubber band right now. When it was sent to me after its initial problems that it had, its owner wanted me to repair. It also endured some shipping damage. When it got here, the head was off, top of the body is separated, and leg linkages, which may or may not have been broken before, I don't know, but they're definitely broken now. So what I thought we'd do is I'd take you through and show you the toy and its guts, and then in the next video or next two videos I'll show you how I'm hoping to repair it by 3D printing new parts to replace the parts that are broken. So to start with, let's flip it around back. It has a battery box cover. These are normally missing on this toy, so I'll probably CAD up one of these too, so a new battery box tank set can be replaced if you happen to find one of these where that's already missing. I'm pulling the rubber band off now, so nothing is holding this thing together except for my hands. I'm going to see some pieces here in a minute. And basically you just push on this and pull off, so you can see there's some very thin little tabs that tend to break, and then once those are broken, the kid loses it, and that's the end of that. Here's where the 2D cells would go. I've already straightened out these metal pins. This is the gearbox inside, in fact, is metal, but the rest of the robot is plastic. And I've straightened those so that we can take things apart a little bit quicker. The outside of the legs, this part, is non-load bearing. This is cosmetic, as is the top of the foot. This is cosmetic, and the pink base part is cosmetic. Now, one of the problems in getting to repair these is this foot part is glued. In other words, the top of the foot and the bottom of the foot are glued together. And in order to get in there to replace the parts that are broken, I've had to go along and carefully cut using an X-Acto knife till I got through all of the plastic and separate the two pieces. But again, that's just a cosmetic thing. It's not load bearing. The load bearing part is these wheels are connected to a little metal frame that you can see riveted here, and the leg linkage parts that we're going to need to replace then connect to that metal. So it's load bearing from the wheels to the metal to two leg linkage pieces up into the metal gearbox. So if we set this guy down here, autopsy mode, we'll take the front off. So here we can see that originally the toy was held together with 4 screws, had 2 down in the crotch area, and there are splits visible there, but at least those 2 are still there. It had 2 at the top. This one is still present. This one is missing, broken off. Other than that, this part of the body is cosmetically in very good shape, considering how old it is. The arms are in good shape. These are the mechanical links, so that's good. We don't need to do anything to the arms. The head, like I say, normally is there's a little flange here. When the body halves pinch together, they bite on either side of the flange. So if the body halves come loose, then the head can come off. And these are the wires that go up to the light, and you can see it's a regular screw base lamp that's up in there. I haven't even tested it. We may have to replace the lamp, but if we do, we do. Other than that, the head itself is in very good shape. And we're starting to get into the real problem parts of this. Let's lift the gearbox away from the body back. Now there's still some wiring involved here. I'm trying to decide whether I want to leave it. I'm going to leave the wiring for now. If it becomes a problem, we'll deal with that later. There are two axles that are going to need to be removed. But first let's just take this one leg off. Yep, see, this piece is broken. Here's one of the lower axles, and here's the other lower axle. That's what the leg linkage parts fit into. So here's one that's sort of still together. Now to get this, to replace these parts that are broken, see this whole upper part, before I get too far ahead, this front part of the leg, this is the front, this is the rear. This normally would be attached right there. And this is where the crank goes to move the leg. This pin interfaces with the arms to make the arm swing. So obviously that one's broken. And to get these off, you have to be able to lift the pink part of the foot up so that you can get to these two axles down here to release the linkages, like so. So now you can see the inside of the foot where I said the wheels go to this metal part of the frame. That's the load bearing part. In here you can see the ratchet is just on the rear wheel. Ratchets still seem to work very well. So now we should be able to remove the foot cover, get that out of the way. Now the rear one has nice big slots, so you can take this whole rear piece, turn it, and you can lift it out, which means we should be able to replace this rear piece the same way. As you can see, this particular one isn't broken, so when we go to design the new ones to 3D print, I'll measure off this one since we know it works. This is a factory joint. I noticed all of the leg linkage parts were joined together that way. They went so far and then they did a join. What's buried in there are two wires, and they actually melted them and hot pressed the two parts together. Very strange. This one, the front one, the one that had this part broken off of it, it can't escape because the slot that it comes out through the bottom is very small and the part that's up at the top is very big. So what we're going to do is we're going to pull it apart in those two wire joints. You can actually see I've started pulling this one apart so it wouldn't be so hard. So you can see there's two little wires that they put in there, and now we can remove this from the leg. And you can kind of see how that joined into the holes right there. Isn't it? It's very strange. I've never really seen an important load-bearing part held together with metal pins like that. And they wouldn't have done that to assemble it on the leg, because they would have glued the two leg halves together after they'd already put these parts in there. So I think it had more to do with the length. This is the longest part. This is longer than the legs because it went below and goes above. It's longer than the body parts. This piece, especially when it's complete, I think was too long for their injection molding machine. They designed this robot to be made with a smaller injection molding machine, so in order to do the parts that way they had to two-piece all of these linkage parts, and they just followed suit even with the rear one that way. Now on the other leg, let me pull the pins on it so we can get in there. Get the foot off. This one This one I'd already glued this part back on. This is the rear linkage, leg linkage, and it was in fact broken off right there, so there was no linkage, and I super glued that back on there and tried to reinforce where the wires went together and all that. This is before I decided that the only way this thing was going to be fixed is if we just 3D printed new leg linkage parts. So that was my attempt at a repair to see if it was going to be possible to save the original components, and it's not really. It's not a good solution. It won't last. And here we have what's left of the front linkage, and it actually was broken. Here's where the two metal pin parts are, and it was broken below those two metal pin parts. Interesting. I'm not even sure why that hole is there. Was it in the other one? Let's look. Yeah, it was in this one too. But this one was broken there, so it had no control over the leg, because you see this goes down, and the crank in the gearbox is going to run in this slot to make the legs go forward and backward. If you're not familiar with what the crank is, then let's put this back together so I don't put pressure on the... So this is the gearbox. Here's your motor. We'll put spray cleaner in there and lube up the bearings before we get done with everything. And here's the cranks, one for one side and one for the other. Here's a clicker. I guess that this comes around and hits. This is the light flasher, and since the only light in this particular one was on the heads, that's going to make the eyes flash off and on. What's left of the switch is back up in there, which you can't really get to, so I'm hoping the switch works. The captive screw parts on this back panel are good on the bottom, and good on the one side that was broken off on the inside, and the side that still had a stud, this one is missing part of it. If I can find that little chunk, I may try gluing that back on. Then I might just have to try to figure out a new stem for that. Here you can see some glue where the head used to be glued on to the body back. So this is what we're looking at. We're looking at designing, well, the rear struts aren't symmetrical, so I'll have to design two of these. Well, actually I'll design one and then use the mirror function to make the other one, because they're opposites, and the spacing and the length on these parts, and whether that faces in or faces out. So I'll design one of these, mirror it to give us a left and a right, and then I'll design one of these for the front linkage, and it will be symmetrical. And I think in order to slip it down into the legs, I'll probably make these parts separate, since they're just spacers. And you can either glue them on or not glue them. It won't make any difference. They're spacers. And again, these are spacers, but they do tend to stabilize and take the wobble out of the legs. So I think I'll make this leg print flat this way for strength-wise, so it's less likely to snap. And go ahead and print, you know, whichever one's longest probably. Print that as part of it, and make the other one that gets glued in place. But that's the project, such as it is. I think we're going to try to save this, so stay tuned for part 2 when I've done some of the CAD work on it, and we'll take it from there.